Hi everyone, I'm Devanshu and today we are going to talk about list resizing. So the story starts something like this. At the start we had arrays, right? And to use them you needed that initial capacity, the initial set of elements that you want to store. And that's why you could only write something like foo is equal to new int 5, which says you can only store 5 elements in this. There's no way you could on the runtime decide, okay, no, I need few more elements now. You could not do that, and hence it was sort of cumbersome. So people thought, okay, we need arrays, but we also need to remove this constraint of providing the initial capacity. So enter lists in C sharp and vector in C++. So what this enabled you to do is that you could write something like foo is equal to new list int with no initial capacity, and you could just use it like a normal array without any problems. We are going to look at how this was achieved, right? And with everything that you do, it comes with some side effects. So we are going to look at that side effect that happened due to this, and we're going to figure out one performance issue that can happen, and we're going to see the solution for how to not let that happen, right? So let's look at some code, and I want you to figure out or just write your answer on some piece of paper, which code is slower or which one is faster, or whether there is really no difference, right? Okay, so here's the piece of code, right? uh, you're going to store 100 million elements, and look at the code, right? You are initializing with no initial capacity. This is what uh, the function name means, and then you keep on adding elements. You add 100 million elements to it, and then the other piece of code with giving it the initial capacity, we write something like n. We upfront say that okay, we are going to store n elements, but that doesn't stop us from storing more elements. We could store less elements as well, it's just that we at least need n n elements. So we again do the same thing, we just keep on adding it, adding 100 million integers into it. So now the question is, which one do you think is faster, right? I'll pause for a second. One, two, three, and okay, so here's the result. Let's look at the result. So I ran some benchmarks, and you can run those benchmarks yourself using benchmark.net uh, NuGet. I'll post that link in the description. Okay, so if you look at the results, there's a huge difference. There's a huge difference. With initial capacity, it took 1300 milliseconds, and with initial capacity it only took 869 milliseconds. There's a huge gap, and the gap is around 450 uh, milliseconds, and if you do some small math, you'll reach that okay, we are actually 52% slower, which is significant. Of course, these are test conditions. You won't see this level of degradation in prod environments. Even if you normalize it to real world conditions, you'll still reach to around 20 to 30% performance difference between these two. Okay, so now we have the benchmark. Now let's try to figure out why this is happening. Okay, so how are we going to figure out? We are going to do what we do best. We are going to look at code, some more code, and this time we are going to look at the actual .NET implementation for lists. And what is this magic that makes us not provide the initial capacity that was needed in arrays, right? And since we are looking at code, I'll try to explain why this dip is happening. And I would like you to notice two functions: the constructor of the class and the implementation of add function. So let's look at some code. Okay, so we are on this website refinesource.microsoft.com and we are looking at list.cs. So in the comments it says what is the purpose of this class. We are going to implement a generic dynamically sized list as an array, which gives us some hint that internally we are still going to use arrays, but we are going to do some more things to make sure that it stays a dynamically sized list. And we are going to ignore this generic keyword right now. We'll talk about that some other time. Okay, so there's one more comment here. What this again says that we are going to implement a variable size list and we are going to use array of objects. We are going to use array as the storage mechanism for our data. And then there is a concept of capacity, which says that this is the allocated length of the internal array. So understand this. There's a concept of capacity and it's a concept of size. The difference between these two is that capacity says that this is the total allocated length, and what size means is that this is the actual number of elements we are storing right now. So it could very well happen that the allocated length, the capacity, the total number of elements you can potentially store could be something like 16, but you're only storing, let's say, 9 elements till that time. And as you keep on adding elements, the size keeps on increasing, and once you have to, the purpose of this is to have a dynamic sized list, right? So which means that there something has to happen once the size reaches capacity. As soon as you store the 16th element, something has to happen to make sure that the next call that is going to come, that is to store the 17th element, you need to have that extra space there. Okay, so let's go ahead then. You have this this is the array that we were talking about in the comments, and let's ignore what this t means. For our purposes, this t is equal to int, so I would like you to read this as private int array items. This is what it means, and just replace all the t's with int in your head for now. Okay, so then you have, as I had said, you have a concept of size and then you have a concept of capacity. And what this says is that this gets and sets the capacity of this list, and what capacity means is that capacity is the size of internal array used to hold elements. Cool. So this uses a concept called getter and setter. If you're not sure what that means, I would request you to read that read upon that. Okay, so but just assume that capacity, for now, in very basic definitions, capacity is a variable, and either you can get the value of capacity or you can set the value of capacity, which of course this is how every variable operates, right? There's no such difference, it's just that we have some extra set of code that is there, but the essence is same. Okay, so we'll look at what this piece of code means later. Let's look at the constructor for let's look at the constructor. Yes, so this is the constructor that we used, and this the other constructor that we used. We are not passing anything here, so let's see what happens when we don't pass anything. It says that we are going to assign empty array to it. And what is empty array? You just pass 0 elements to it. You don't have any capacity to store any elements right now, and when you pass in the capacity, it sort of goes in and checks some base conditions and then says, okay, if you are passing me the capacity, I'm going to assign that capacity upfront, which is a big difference, right, in these two cases. So if we come back to this piece of code, here we are essentially at the start of it you have empty array, and here you actually have an array which can store 100 million ints, right? This is a huge difference. So on one hand you are not allocating anything, on the other hand you are allocating everything. So I think this should give you some hint that this empty array, it has to store 100 million elements, which means internally something has to happen to increase the size of the array. And of course, by definition, once an array has been allocated, you cannot change the size. So what is the catch here, right? And then I guess the answer would be clear once you look at the code. Okay, so we are going to look at the code for add now. Let's find add. So what happens in add? When you call add, we are going to check whether the size, and what was size? Size was the number of elements we are storing right now. If size is equal to items.length, which means that the array is full, there's no more space to put more elements, right? Which means that, and then if that is true, we are going to call ensure capacity. But notice the next line, it just does items of size plus plus is equal to item, which means that at this line it assumes that there is space, and this is a very big assumption, and I guess this should give you a hint that something happened in this function which magically increased the size of the item array. So which gives us the hint that let's look at ensure capacity, and for example let's assume that size was 16 and items dot length was also 16, which means that we're going to call ensure capacity with a value of 17. 16 plus 1, 17. Okay. So let's look at it. So we come in and we check whether items dot length less than min, and items dot length was 16 till now, it is still 16, and we check if 16 is less than 17, which it is. Whoa, what is this? We say that we're going to calculate a new variable called new capacity, and we are going to multiply the current item dot length what was the current item dot length? It was 16. So the new capacity becomes 32. So if you notice, we just calculated the new capacity, which essentially says that we're going to store 32 elements now, but we don't see any changes to array right now, right? And this is where the concept of setters and getters come in. So this is the place we're going to look at this piece of code. So if you notice, we are assigning that value here, we do some basic checks, and then we assign that value to capacity. So let's, and since we are setting the value, we are going to look at the setter part of code. So what this does, it again does some basic checks. It does some basic checks which says that if the value is not equal to item sort length, so remember the value will be 32, that will come here, right? Since we are setting 32 here, and of course 32 is not equal to the current length, which is 16, and of course the value is greater than 0. And notice what we are doing, we are allocating a new array. And what is the size of the array? The size of the array is 32. And notice what do we do next? We copy all the things that was in items to the new array that we allocated new items to new items, which means that, so I think you now get what list resizing means. It means that as soon as the size as soon as there is no space to store any more elements, we are going to increase the size by 2. And how are we going to do that? We are going to allocate a new array. We are going to copy all the stuff that was there in the previous array to the new array, and then we are going to assign the class variable as the new array. And this is, in essence, is called list resizing. We were here. So now the question is, what just happened? There's a difference in constructor. On one hand, you were allocating an empty array at the start of the operation, and then there is a resizing that is happening whenever you have no space to store the elements. On the other hand, you do one-time allocation, the array can store 100 million elements and there is no resizing that is happening until there is some space. So yeah, so the magic that is happening is the ensure capacity function that is being called. So let's look at what is the cost whenever you call ensure capacity and it causes a new array to be allocated. The cost is you allocate a new array, the allocation cost, and then you copy all the elements into the new array. And if you notice, the cost is linear. To allocate n elements, you have to pay some cost that is proportional to n elements, and of course copying elements, n elements, take order of n time, and as it goes, without saying, as the size increases, we start paying more cost. And when do we pay this? We only pay when the capacity is full. So which means that we have to think about how many times this resizing is happening. There's also one more thing. In managed languages like C#, there's a concept of garbage collection, which in very simple terms means that you allocate all the objects, don't think about freeing that memory space that was allocated. Someone is going to take care of it, and that someone is garbage collector. So if you allocate something, it has to be garbage collected. so that you just don't keep on hogging the RAM that is present. So garbage collection happens, then it basically cleans up all the intermediate arrays that you allocated. So whenever you resized, you created a new array, you allocate memory for it, but then you discarded it when the size was again full. So you have these stray intermediate arrays in memory that needs to be cleaned up. There's also one more concept of large object heap that comes into picture here, but we're not going to talk about that right now. Now the question is, how many intermediate arrays will you allocate? The answer to this is basically asking how many times you will call ensure capacity and when it causes a reallocation. So which basically means how many times will you reallocate the elements. So if you remember, it was 100 million. 100 million is 10 to the power 8, and you start with size 0, then you look at the base case in the code, then you go to 4 size, and then you go to 8, then you go to 16, which is 2 to the power 4, and then you keep on going. How did I come with this 2 to the power 26 value? You just take the log to the base 2 of n, which sorts of comes to 26, which means that you're going to do this reallocation, you're going to do this resizing 26 times. So now the question is, are you getting what is the issue? When you do list of n, you allocate memory once, you never resize it. Garbage collection only has to happen once. Only allocate memory once, and that is the end of it. On the other hand, the list keeps on resizing again and again. You create intermediate arrays, you copy elements from one previous array to the new array. So the answer is, since you are doing a lot of resizing, there is a hit to the performance. So the answer that we have is that if you can always provide the initial capacity, if you are going to provide the initial capacity, the resizing is not going to happen. And if the resizing is not going to happen, then you would save upon the allocation cost, the copy of elements cost, the garbage collection cost that you're going to pay. Said, as the numbers we saw, this cost is significant. So I'll stop here. Thanks a lot, and do subscribe and hit a like.